friends. We in previous video lecture we stopped at this point. In a neuron there is a Z equation and A equation. Z equation corresponds to the input weights and bias summed together, and A is some function applied to Z. For each neuron, there will be Z function, that is Z equation and A equation, right? For every neuron, if there are 100 neurons, then you will be having 100 equations. So instead of writing equations for each and every neuron, we can have a general equation for a layer which will consolidate the Z value and A value of all the neurons present in that layer. Okay, so for that purpose we consider Z and A as the vector. That is called as vectorization of Z and A. So we have already discussed in previous class about the sigmoid function. So this is vectorization. So instead of writing Z and A for each and every neuron, we write it for a particular layer. So the first equation here, Z to the power 1 in the bracket, 1 in the bracket indicates the layer, is equal to x to the power 1 tx plus b of 1. Here we don't have w, it has been replaced by x to the power 1. It means the weights of all the neurons present in the layer 1. That is what x does. So the first equation computes all the intermediate outputs Z in a single matrix multiplication, and the second equation is corresponding to A. The second equation computes all the activations A in a single matrix multiplication. So we are converting Z and A as the vectors. Then shallow network forward propagation equations. In a network there is a forward propagation and back propagation. So forward propagation means moving from the input layer to the output layer through hidden layers, whereas the back propagation is moving from the output layer to the input layer through hidden layers. Now here we first take the forward propagation equations of this shallow network. As the back propagation is concerned, we will see in the other topics in future. So here network forward propagation equations will be Z to the power 1 equation, that is Z corresponding to the layer 1, and A to the power 1 equations, then Z to the power 2 equations, right, and then Y equation. So the first equation calculates the intermediate output Z to the power 1 of the first hidden layer. The second equation calculates the final output A to the power 1 of the first hidden layer. The third equation calculates the intermediate output Z to the power 2 of the output layer. The fourth equation, that is the Y, which is the final output of from the layer 2 of the output layer, which is also the final output of the whole neural network. So this is the forward propagation equation from the input layer, then the hidden layer, then the output layer. We have a small quiz here. Okay, first question. Neuron is equivalent to A node or B weight or bias or activation function. So that is, the neuron in our biological network is equivalent to what in artificial neural network? The answer is going to be node, right? It is equivalent to the node. Okay. And second question, identify the hidden layer in the below diagram. So the below diagram shows the diagram of a complete neural network. This diagram we have already seen in previous slide. So identify which color layer in the diagram represents the hidden layer. So the orange color, right, layer represents the hidden layer. A green color layer represents the input layer, whereas the blue color layer represents the output layer. What function represents the below function? Sigma of x is equal to 1 divided by 1 plus e to the power minus x. So this is obviously a sigmoid function that we have already discussed in the previous slides. Thank you. So this is about the neural network introduction and then shallow network. So what is shallow network? Shallow network is a network with few hidden layers, like one or two hidden layers. So in the next video we will discuss about the another uh, deep learning technique, a classifier, that is the support vector machine. So till then, thank you all of you. We'll meet in the next video lecture. Thank you.